So the mean of a probability experiment is also called its expected value. So when we find expected value, we need to make sure that we're considering all possible outcomes of the random variable. And the thing that can make expected value questions a little tricky is making sure you have the correct value of each outcome. So let's consider this example, and you'll see what I mean. So say we have a lottery game where it costs you $1 to play the game. You pick a 3-digit number, and you win $500 if your pick matches a randomly selected 3-digit number. And okay, digits are, I didn't say this, but digits are 0 through 9, so there's 10 possible values for each digit, and they can be used more than once. So what is the expected value of each $1 bet in the long term? So we have this probability experiment where we play a game, and there's two possible outcomes. Either you win the game or you lose the game, right? There's no other possibility if you're playing the game. So I usually make a table. So we have the outcome, which is you can either win or you can lose. There's only two possible outcomes for this probability distribution. Then we have the value of each of these outcomes. And then we have the probability of each outcome. Let's call that P at X. All right, so the lose is easier. If you play the game and you lose, what have you lost? You've lost $1. The tricky part here is making sure that you assign these the correct sign. So the lose, we're going to lose $1, and we can label that, but in our calculations we won't use the labels. And then when we win, here's where a lot of people get this wrong. When you win a lottery game, and the jackpot is $500, you haven't actually won $500. You've won $499 if it costs you $1 to play. If it costs you $5 to play, then you won $495. So you have to subtract what it costs you to actually play the game from your winnings. So the value of the win outcome is actually $499, not $500. So you have to think about your net gain or loss in these values. Now the probability of these outcomes, since we're selecting a 3-digit number and numbers can be used more than once, then of course the number of outcomes would be 10 cubed, right? 10 times 10 times 10, or 1,000. And only one number is going to match, so to win, the probability would be 1 over 1,000. And to lose, the probability of losing would be 999 over 1,000. And you can make these decimals if you like. So the expected value would be, of course, the sum of the value of each outcome times the probability of each outcome. So the value of winning is $499. Its probability is 0.001, or you can use the fraction. When you do this, make sure you have a negative for the outcome of losing. And of course the probability, whoops, I'm sorry, I need to move this up. The probability of losing is 0.999. So when we put this in the calculator, so we can just move that over, the decimal over 0.499 minus 0.999 will be negative 0.5. And this would be in dollars. So what's the interpretation of this? Well, obviously this isn't an outcome ever if you play this game, right? You're either going to win or you're going to lose. You're never just going to lose 50 cents. The interpretation is negative 50 cents or $0.50. So the way you want to think about this is it's an average. If you play this game many times, eventually you're going to win. But what are your average winnings? Because you've played it so many times, on average you're going to lose 50 cents per game. So that's the interpretation. So if we play this game many times, we can expect to lose, you can say 50 cents or use dollar notation, 0.50 per game. Now I did the expected value to us as the person playing the game, whoever's playing the game. You can also do this from the perspective of the lottery. Notice here I put lose, so that represents my negative sign, right? If I do this from the perspective of the lottery, what would change is this would be their payout. This is when they lose, so this would be negative, this would be positive. Their expected value would be positive, so it would just be the opposite sign. So like in the worksheet, when I asked the expected value to the insurance policy, or to the insurance company, again, what your answer there isn't going to be any particular outcome. That can't happen in just one situation, but it's what can they expect to gain or lose on average from this policy if they sell many of these policies. So of course they want their expected value to be positive. It doesn't make sense for them to sell insurance policies if their expected value is negative. That's how they decide if they're going to make money or not. If their expected value is positive, then it's probably a good policy for them to sell. So keep that in mind as you're doing these problems. It can go, depends on the perspective whether the answer is positive or negative. Make sure you're doing it from the right perspective. So for us, playing this game many times, we're going to lose on average 50 cents per game. So it's not a good game for us to play if the expected value is negative. You may remember when the Powerball jackpot got really huge a few months back. The probability of winning the Powerball is very small, but because the jackpot was so huge, there was those couple of times there where that expected value was actually positive to the player rather than negative, and that's probably the only time you ever want to play the lottery. Anyway, so there you go. That's how you would do an expected value problem. Main thing again to watch for is making sure you get the net value of these outcomes. So just be careful.